Hey,
Hello.
how are you guys? Good. So you just back from class, Nathan?
Yeah.
All right, okay. What's up? What's up? So yeah, Yam said you have a bunch of questions.
Yes.
Yeah.
So we actually made a doc, so I think it may be easiest if we just share. Today's the Windows partition. I was just playing games with my brother. All right, sweet. So we have pretty much a couple of
Can you hit
questions.
a control plus, Yam?
Yeah, for sure.
Thanks. That's great. That's great. Okay.
So we have a couple of questions about C++ design philosophy. So basically, what we're trying to, and this isn't wrong, this is just VS Code not getting stuff right. So we have some questions about C++ philosophy because we aren't sure how to structure our code for C++ specifically. So right now we have a classification function that will train given some input, right? And will create a specific hash table, right? With the frequency of each input based on a specific author, right? That's an input, right? But we want to know how we will save these inputs into some kind of file in like a C++ way, right? Because after all, after training it, right? Training takes a long while. We want to be able to save that in a file and not have to retrain every single time we're running. So we're wondering how to do that in a C++-esque way. So that's like
okay. All right. So do you want me to answer this question? Then we can move on to the next one.
Yes.
Okay. All right. So I don't know about C++ philosophy or what is the recommended way to do things. I only know how I do it. So I can tell you what I do and you can see if it works for you. If it doesn't, you've got to do some research and find out what works for you. Yeah?
Okay.
Okay. So so you have written a function that would read in a string of words, presumably, white space delimited words.
Correct.
Const string, and it's I see it's a const string, and it's a huge file. It could potentially be a huge, enormous string. I see. Is there a reason why you chose to pass a string instead of a stream, like a CN or like a file input stream or something like that?
So we already we have a file input stream that we.
Yeah. So why don't you just pass that instead of getting a line and passing each line?
Okay, so use the in files get line instead. So instead of making
just make a note. Don't do anything now. Just make a note.
Yeah.
This is just questions you can ask to refactor eventually.
Yeah.
Yeah. It doesn't matter how you do it. It's just we just need to know how the things fall into place, and then you can refine each part later. Yeah.
Yeah, makes sense. So
okay.
Instead, so like pass in an input file stream.
Consider passing in a here. Okay, so consider the signature. So no, just say consider the signature, right? Consider the signature. Okay. And so so the signature could be I see. So let's. So I want to figure out what this does now. And you're saying, okay, so you're going to give it some strings, and it's going to count all the words and produce a hash map and stuff the hash map and return it. Yeah. So like 10 lines of code, 10 or 15 lines of code potentially. So string. So it's going to stuff a hash map, and it's going to be counts, not relative frequencies. Okay, because they're ints. You could make them size t because they're all going to be positive, unless you have a negative sentinel somewhere. Yes. You have sentinels?
We do not. You're right. They should be size t's.
Yeah. Don't worry. Yeah, they're all just notes. In successive iterations, you'll just come to your mind. Yeah. So as you're refining the code, repeatedly, just like anything, right? You start off with a rough shape and then you chisel the edges off and just polish, and eventually it'll fall into place. But when it does, you'll remember these things. Yeah, okay, all right, into size T and all these things. Yeah, okay, cool. So I'm just raising these issues that will potentially cross your mind later. Okay, so you're getting the line, breaking into strings, breaking into words, and then stuffing into a hash table that you're creating inside of this method. Yeah, where are you creating? Oh, yeah, you're creating the unordered map right there.
Yeah, so we're planning to make an unordered map for every single author.
Where's the hash, right? Hash function for that unordered map? Where is the hash? Oh, it's an yeah. Where is the hash function for the key?
So we haven't created it yet. I'm assuming it's the standard hash function, right?
Yeah, okay. So it's probably using the default internal string. That's good enough.
Strings.
Yeah.
For strings, it's great. Yeah.
That's good enough. Okay, so it's using right, and you're taking these things and putting it there. And if the word no, hang on. Can you scroll up a bit more?
Sure.
Yeah, getting a line, and then for each line you get all the. Oh, and then you do some cleanup here. Is alpha.
Correct.
Is that what you're doing there? You're doing some cleanup there?
We're getting,
all right, so
getting rid of all exclamation marks, periods.
Okay, so here's what I suggest. Okay, so can I just like in 2A, can I just dictate a few lines of code, and then you can in comments you can go right to the top. You can go right to the top. Go to line 45, hit enter. Okay, and this is just one proposal, and you can think about it. Okay, so all right, so a frequency trainer, you have a method called frequency trainer, and it's going to return a hash map. Okay, all right, so here I think is it's a slightly better signature of this for this function. Okay, so say and it's not a trainer because it's actually training. No, actually frequency trainer, no, this call is to train. So you can say count words. I think that should basically call, yeah, you just say yeah, and then make it return void for now, and we'll change later. Okay, so void count words, void count words, and then open parentheses, and in there you could say const no, not const, I'm sorry, hash table, whatever that signature is for the hash table, space,
pass in a hash table by reference, right?
Yeah, exactly. Yeah.
Okay.
Comma, and then
input file stream.
Input file stream. Yeah, exactly. Input file. I think it can just be input stream. So this function doesn't even need to know whether it's a file stream or a console stream. It doesn't matter. A socket stream. It just be an input stream. You can do some research and find out.
And an input stream is a parent of a input file stream, etc.
Something like that, yeah. Just do some Googling, and I think that you can call this with just CN too. Just as well, you can call it with a file stream.
Okay.
But I think if you make it IF stream, then if you try and call it with CN, it might, the compiler will complain.
Yeah, I don't think we'll need to use CN for it.
No, you can. No, you should. No, all right. So see, put a semicolon there for now. Put a semicolon. Yeah, no, actually, no, let's complete this method. Just as a space curly brace,
Sure.
And in here, see, all this is going to do is really while you just say while whatever that stream is, stream right shift into word,
Yeah. Oh, that's what you mean by CN. Okay. Yeah. Just stream notation. Okay.
Yeah. Stream right shift into word.
Yeah.
And then you can and in the body you're basically going to say what is it? You have a hash. Yeah, you have a hash passed in. So you got to say if hash dot contains word, then plus. Otherwise, hash contains word equals 1.
Right. What about cleanup? Because we're going to need to do first of all
cleanup for punctuation. Right. So that's why I said that's all this function is. That's it. So no cleanup here. We're going to
Okay,
assume.
so this function assumes space delimited words with no punctuation.
Yes.
Okay. So let's
That stream has got to be
specify
like,
that.
I'll show you how to do that too. Don't worry. Okay, this is all. That's all the function is.
Wait,
And you could figure out some value to return, or it could just be void. You can figure out a value saying, okay, total number of words that have non-zero count. Yeah, something like that. Vocabulary size, right? And you put a comment there saying return vocabulary size. Return vocabulary size, and it could be size t.
Wait a second. Then
yeah, actually, just say yeah, we'll change the comment underneath. Yeah, return vocabulary size, and yeah, vocabulary size, and it's not void; it'll be size t.
Yeah.
And then the last comment that you wrote, space delimited I stream, you could basically say input. The input stream is a stream is a stream of cleaned up words or normalized words. Some people say canonicalized, normalized, doesn't matter. Just cleaned up is fine. Yeah. Normalized words. Now, the way this usually works out there, and I think it is also good for students to do, even though it's done out there and professionally, right? So the right way to do this is the C++ does what C++ is good at, and this is it. What goes into C++ is cleaned text, and there are lots and lots of things out there in Unix that can do text cleaning much better than C++ can. So I'm pretty sure that you can write a couple of PHP or Python scripts.
That would be way easier. That would be way easier to read, though.
Yeah, exactly. Or Bash scripts, and that will take a stream coming in, because Unix is basically built over streams. Yes.
I'm not.
I'll show you. Just Control Z. Are you on a Linux terminal right now?
No, but I have a git bash.
Yeah, get to a bash shell.
Yeah, there you go. The bash shell.
All right. So all right. So just a cd to /temp or something. Oh, you don't care about what you create in this directory? No.
Yeah. Let me just make clear.
Yeah.
There you go.
All right. So let's say we want to all right, let's create some junk first. Yeah, all right, so type seq hit tab one more time. One time. Okay, maybe the see how do you get exe there?
Because it's git bash. This is in Windows. So
it's in Windows. Yeah. Oh, yeah. I see. Okay, all right.
This is my Windows partition. Yeah, it works just the same.
I've never done this. Okay, so
it's really cool.
So we'll see.
Wait, Nathan, do you want to try it too, just to make it sure that it works on your computer as well?
Yeah, sure.
No, I know. Sometimes it's just easier to run a Docker shell. Like that's what my 2B students do in their extra credit project. Is they have to do something in Linux, and rather than partition your hard drive and risk great things, so they just download a Docker shell and run it. And you get it in like a couple of minutes, right?
Yeah, I don't know. This is fun. Also, Linux.
Yeah, I know. Hey, this is for the brave. This is for the brave people. Okay, all right. So type seq space I don't know, -10 maybe.
Sorry.
10 -10.
Okay.
Huh.
So
just say seq10. Just say seq10. Wow.
Okay. So it's the sequence command. Okay, got it.
Why? But maybe it's all Windows style flags. Well, what about seq? I don't know. Maybe -H. I'm pretty sure -help or -.
Yeah, it's minus help.
Okay. It does do a little bit of Linuxy things. All right. Okay. So let's put sequence 10 in a file. Yeah, sequence space 10 and greater than 10.txt. Yeah. Okay. Cat 10.txt, and let's make sure it's there. Okay. Yeah. Excellent. Now let's say we want to replace all of the new line characters in this file with, I don't know, Yamm and Nathan or something like that. Okay. Do you know how to do that?
Sadly, no.
So
I don't know how to do it in Python, but
I don't know how to do it, and we're going to try and do this right now. Yeah.
Okay. Let's go.
All right.
How about we make a bash script to do it?
Yeah, well, let's do it on the command line first, and if it works, you can turn that
into
a bash script.
Okay.
So do cat 10 dot cat 10.txt, pipe it
Okay.
to all right, tr. I think that's tr. This transliterate tr.
Let's see if TR works. Oh yeah, it is.
Yeah. By the way, you can also you can. No, I know how to use tr.
Okay.
So just go pipe it to tr space.
So Nathan, do you know what the pipe is?
No, I don't. But what does
Okay.
this do?
So first of all, cats is just print, right? It's print to the output stream, right? And then pipe takes the output of what's over on the left and pipes it as the input to the next command, right? So that's the
Okay.
input to TR now. So we're gonna have some input into TR.
What does TR do?
I have no idea. We're gonna find out.
Okay.
This is TR, translate, squeeze, and/or delete characters from the standard inputs. So the standard input is like the input that we're piping in. So have you ever seen, like, if you mess with Python, you can like see that the print actually goes to the standard input and the standard output, and it's pretty cool. Okay.
All right. Okay. So let's replace. So tr, Nathan, basically is a command that can replace characters. It's really cool. And the power of Unix really comes from not individual commands, but the way in which you can combine these guys and do crazy things with, putting them in combination, saying, hey, I'm going to take your output and attach it to the input of this guy, take the input of that guy and attach it to the output of this guy, and all these things. You can do these crazy things like Lego blocks. And that's what's about.
Yeah.
So that's what we're doing here. We're taking the output of the first program, cat, and connecting it to the input of the second program, tr. So that's what Yamm was saying before. Right. So let's try and replace all new line characters. And I bet that you can do no, I don't know if you can do /n. I think it is slash. Oh, it does take a /n.
Yeah. It's a /n. It says over here. /.
Oh, cool. All right. Well, I always used to do octal codes before. Okay, space. Now just do tilde for now. We'll see if and hit return. We'll see if it actually does it.
Okay, so tilde is nothing.
Just hit enter. It didn't do it. Put a dash. Maybe tilde got up arrow. Don't use tilde. Just say dash.
Yeah.
No, it didn't do it. What about maybe? Oh, this is Windows. Maybe you got to do /r. No. Go back up and do /r. No. Instead of /n.
Because it's not /n. There are no /n's, like you're saying.
Yeah. Maybe I'm guessing.
Okay,
that's funny. All right. How about just replace the number? Just replace number 5 with dash. We'll see if you can replace the number 5 with dash.
Yeah, that's
I don't know. The escape sequence is working.
Okay, yeah, it is. Right. It is okay.
So the escape sequence is not working. So go back to the instead of
I think maybe we can try this.
Yeah. I think the slash was taken by the shell before. In
that case,
you guys... Great. Yeah. All right. So all right. So now.
And you were saying tilde?
What were we trying to do before I forgot? So we were trying to
make it as empty as spaces. We're trying to make it as spaces.
Oh yeah. No. We wanted to say we wanted to replace all the tildes. We wanted to replace all the, we wanted to put say Yamm and Nathan at the end of each line.
Sure.
Yeah, I think that's what we wanted to say. I don't know that you cannot do, right? Because tr is a very interesting command.
Ooh.
It is so fast.
It's only for characters.
Because that's the reason it's tr is character replacement. That's why it's O of 1 replacement, right? If you give it a string, it has to scan the string, and it's not O of 1 on the thing anymore. So that's why these streams really work really fast, and they just zip through because it's one character at a time.
Okay.
Yeah. And
so this one actually work. Okay.
Yeah. So the way to do it is get them into dashes. Get them into tilde. No, not tilde. Yeah, put tildes there. Put tildes there. No, let's not use tildes. Let's use something else. Put a ampersand. No, they put the @ sign. At sign. I think that's
cool. @ sign. Sure.
Yeah, at. Yeah. Okay. All right. Great. Okay. Good. Now pipe the output of that command. One more pipe. Now we're going to send this to another command, and that is called a stream editor. Okay, sed. And all these commands are all very useful, especially when you're going to be working in data engineering, because you're going to be a lot all right, said. So yeah, there's a, you can't even read the man pages. There's this the way to learn these commands is just to learn 2 or 3 of these options that are really good and very common. And then as time goes on, you'll start discovering more and more of these things. That's the way it works, because there's no way you can learn all the zillion options of sort, for example. Yeah. All right. So now pipe that to sed. And here, what we're going to do is say, all right, say dash n. I believe dash n as don't replicate each line, but we'll forget. Say dash n.
So
space
dash n is quiet.
Yeah. All right. Say dash n. I don't know what quite does, but dash n space dash n.
Dash n is no outputs, like no outputs to.
Yeah, but it will. What is substitutes? I'm pretty sure, right?
Okay.
Space and then single quote. Single quote and say substitutes s. We need a no just s for substitute. S is a substitute command, and then say vertical bar. I know this is a forward slash. Let's use forward slash to make our separate our 3 sections of the substitute. No, within the single quote, s is the command called substitute, right? And then within single quotes, you're going to complete the substitute command. Now there's 3 parts to the substitute command. S is the command. The second part is what you're going to substitute, and the third part is what you're the target. Yeah. So yeah, and no, but you need to have the 3 parts. So you need the @ sign first. The first is
okay. So
the
that's what we're separating with.
No. S
Swap
is
the second and the third one from what you had. Yeah, like that.
Yeah. All right. Now, one sec. Hang on, just a sec. Okay. That. And then
you can try it. It won't do it.
The finals. Complete the command with the final. Now, is that enough? No, wait. You also need a dash G at the end. No, it's like G at the end, meaning do it any number of times. Do it generally or something like that. G says replace.
Like this?
Every occurrence of the hit enter.
Okay, we have to make it not silent so we see it, right? Yeah. Okay, nice.
Why did I use
what happens if we get rid of that? Okay, that's only happens once. Okay, yeah, so you want G.
All right. Now, do you have the dash at all? Yeah, put a dash there. Put a dash there. I don't know if the dash n works. You can put a dash and then use tr to replace it. It does. Sed actually picks it up. So that's the way to experiment and find out anyway. All right, cool. Anyway, so now you put that into another file, and no, actually, you know what? Don't have spaces. Yamm space and space Nathan, right? Because we can do some word counting and all.
Okay, we'll do some word counting as well.
Yeah. Just
okay.
put it in.
Onto 10 splits.
Yeah, I don't know what 10 split is, but let's take a look at that file. Cat 10 split.txt.
That's nowhere, I think.
All right, can you run it one more time? Put a space before the Y also, so that Yamm and Nathan are separate.
Sure thing.
All right, good. All right, so now let's say.
Okay, wait. Could we? Because this is Nathan's first time with command line. Just make sure that we go over everything. So we have like the first thing, which this puts it out to the stream, right? To the standard stream, right? Because cat puts stuff towards the standard stream. If there's nothing afterwards, it'll just display, right? So here, this will just display if there's nothing afterwards. But this pipe is making tr pick it up, right? And tr, Anand, you said was character replace?
Sorry, were you asking me?
Yeah, the
TR is I think it is called transliterate, meaning just change from one alphabet to another alphabet.
Got it.
So the first alphabet could be all uppercase letters, and the second alphabet could be all lowercase letters. Exactly. Okay. But they got matched.
Technically, we don't even need this middle command. We could get rid of it and just change this to a /n here.
Yeah. That is perfectly fine. In fact, there might even be a better, even better way too. So you can experiment and find out.
Oh, yeah? No, it doesn't work.
I don't know. You can find out. Maybe it's possible to do it with just said. Okay. Yeah, or you can easily do it with awk. There's a zillion different ways you can do it. But anyway, so where we're going is now. Let's say you want to count all the words, the number of words in it. Oh yeah. Okay. So you get a file with all of these words in it, and let's say this is your Gutenberg.txt. It may have a whole lot of junk in it. And so you're going to be writing a bash script that says cat star $, which is basically cat input. Oh, let's do a all right. Edit a file saying cleanup.txt. vi cleanup.sh cleanup.sh.
Dot bash, yeah. Cleanup.
Yeah. Yeah, bash.
Could you make it a dot bash file instead?
Doesn't matter, anything. Yeah. Right. So yeah, hash bang, hash vertical bar.
Yeah, it's damn it. It's like
No,
this, right?
it's got to be hash vertical bar.
Vertical bar. It's
No,
an
not
exclamation
vertical
mark,
bar.
yeah.
Exclamation, hash
hash
bang,
bang.
exclamation. Is that an
And
exclamation mark?
Yeah.
It is. No, you
And
need
then
the full
it's
path. You need the full path. /bin/sh.
yes, bin. I don't think there is a /bin/sh in this one, but we'll see.
We'll see. Actually, why don't you hit enter, echo hello world, and then run it. We'll see. Yeah.
Okay.
No, echo hello
then-
world.
Here? Oh, in the thing, yeah.
No, in the script. Just echo hello world there.
Okay.
All right, hit
And
enter.
it needs to be in quotes.
No, it doesn't.
No?
It just takes 2 arguments.
Okay.
It
We'll
takes
see.
any number of arguments essentially, right? So this is the two argument version. All right. So now let's run it. Oh, you have to ch mode. Ch mode.
No, it's
What,
okay.
what is it? Do an ls-l of cleanup.bash. ls space -l. It's automatically executable. Wow.
No, because this is git bash. This is like
Oh,
the Linux.
I keep forgetting.
Yeah.
It's so similar. They're so similar that you keep forgetting. Maybe it's worse to be very similar. It better
Yeah.
be. That's something that it's better to be not work at all than work partially. Right? All right. Okay. That's really cool. All right. So let's go into the script. Go into the script. So it works. It's in the path
Yeah,
now.
that's all good.
Get rid of the line, and then we say, all right.
DD.
So yeah, and then the first sentence you could essentially in the first line you could essentially say cat space
Split.
no cat space $.
Okay.
I'm just giving you a template, okay? And this is really nice because it's going to help in all of the other things you do too, right? And then space 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 and then a backslash. Okay, now go on to the next line.
Okay.
Yeah, and then about oh, is that the first tab? Just
Yeah,
the 4 spaces.
it gave me a tab.
All right, okay.
I think the
all
tab
right.
size is 8 instead of 4.
Yeah, all right, okay. You can change later. All right, so vertical bar. And you can say
Okay, so
lower-
backslash just allows you to go on a new line, right? This is
yes.
okay. So that's not what we're doing is literally just a vertical bar, right? We're just piping
Exactly.
cat into
Yeah, exactly. It's
this
easier
looks
for
nice.
your
This just looks nice.
Yeah.
Okay, good.
and type that to, for example, right? This is, none of these exist. You could say lowercase, lowercase text. Right? So say lowercase text, or you just say I don't know. You can say lower text .bash. It's got to be a bash script, or a lowercase .py. I don't know. You're going to write a script essentially.
Okay.
You're going to say cleanup 1, pipe again to cleanup 2, pipe again to cleanup 3, and sometimes you may have.
Oh, got it. Okay, so these are all our cleanup stages. Okay. I understand
Yes.
what you're saying. Okay.
All right, and the
Yeah,
final
yeah.
output. The final output is basically ready to be piped into your your C++ program, and C++ program is just 3 lines.
Okay, and then
Oh yeah,
Can- can I-
backslash.
okay, sorry. Yeah. We can go. Whoopsies.
That's all, and so
Okay.
and then
How can you pipe this
and then-
into the C++ program though? Because the C++
No,
program,
that's
right?
Final output. And then finally, this the way you run it, you put it in this comment, right? Put this in comments. Yeah, start a comment there.
Comments in bash is like this, right?
Vertical bar. No, hash mark. Hash mark is a comment.
Hash mark.
Yeah. You say usage. No usage. Yeah. You don't say a dot I don't know usage.
Sure.
Usage. And then this is not a.out. You're going to call it what is this cleanup.bash, right? So essentially, what you're going to say is a usage example, and on the next line. On the next line, you can say, yeah, again, inside of a comment. On the next line, inside of a comment.
Yes. Oh man. Still learning how to use it. Okay. It's hard.
Okay.
VI is hard.
You can say, no, essentially you can say cat space Twain star.txt, right? So many Twain files. Yeah, Twain star.txt. Twain.
What's Twain? Oh, it's like
Twain.
Mark Twain.
Twain star.txt.
Okay.
Yeah. Also, there's a whole bunch of files. Cat is going to combine all of them into one stream.
Wait, sorry. You can do cat this and then another Twain 2. You can do that.
Yeah.
Cat
takes any number of arguments, and
wow,
if you don't give
okay.
it, if you don't give it any arguments, it's going to read CN. So if you don't give it any arguments at all, it is going to read CN. If you give it arguments, it's going to read the R. So that is the Unix philosophy. Even commands you write, that's the behavior. Grep, sort, awk, all of these commands. If you give it an argument, it will read the argument. If you don't, it's going to read standard input.
Wow. Okay.
So yeah. So it's you see this is all of these commands. They were born out of thousands and thousands of hours of programmers like you and me, just refining these things. Saying they got some basic version, but they say, well, you know what? If it does this, it is much nicer. It improves our lives.
Yeah.
If it makes this assumption, it's better. And so there are all these beautiful assumptions factored in that many of these commands are just perfect for us. Yeah, and it does exactly what we want. If it takes an argument, it takes an argument. If it doesn't, it doesn't. But it still does the right thing. And so, yeah, that's what makes these commands very nice. Okay, so yeah, so cat Twain star.txt, and then we haven't completed the command. So cat Twain star.txt, yeah, and then you pipe that into cleanup.bash. Pipe that to cleanup.bash. Yeah, is it called cleanup1.bash? Yeah, okay.
We'll call it that. Oh, okay. Our actual.
Oh, no,
this is right. This is okay. Yeah. Well, then, won't this cat not work?
Yeah. No. So here's the cool thing. If you name a file name or when you call this command, it's going to cat that file. If you don't name a file name, it's going to cat the standard input. So whatever you send into the file is going to come in too.
So what's $$ exactly?
Oh, $$ is whatever was named on the command line. If nothing was given on the command line, that's also nothing.
Okay, so cats this, right, is the standard inputs, right?
Cat
this goes into standard inputs.
Cat takes the contents of those two files or many files, because Twain star.txt could be 100 files.
Yeah.
The cat is going to take all of them and concatenate all of them on the terminal, on standard output, on cout.
Yeah.
So
and then,
what comes
and then we take that in. We take that in.
Yes, and that becomes the input for this guy. However, when this guy is invoked, this guy is not given any command line parameters here. So you see that on after cleanup.bash, you just say / and go on to the next line. Yeah, go on to the next line. By the way, the comment you have on the first line will not work, because what happened?
This won't work. Yeah, because they will think that's actually.
No, not that. You take the / and put it on the end, because right now you don't have a / followed by a new line. You got a / followed by a space on line number, on that cat line, on the cat line.
This one?
Yeah, that's not a / followed by a new line. It's a / followed by a space. So you have a shell error, syntax
yeah.
error.
Okay, so
take the / and put it on the end and put the comment there.
Put the comment here, and then.
In fact, get rid of the comment completely. Just put the / there, and you can put the what the command does. Okay. Cleanup.bash, and then pipe the output on the next line. You can say pipe the output to count words.txt. Count
Okay.
words.txt.
There's a proper way to do that with grep, no? Counting words. Oh,
You can-
you mean our count
Yeah,
words function?
Count words is going to do other things too, right? Essentially, we're not right now. You're just dumping frequencies.
You mean our count word functions, like our count word function, like we made in class?
Yeah, that's your exe file. Your whatever you do. That
Okay.
What the input stream is now going to be the that big file after a transformation with the scripts that you've written is going to become a clean input stream that you pass into your C++ program.
Okay, so this count words though was part of our okay, what was this?
Classifier, yeah, you can basically say in fact here, okay, so backslash I mean remove that and say train model train dot train dot counts, train model, train hyphen model, yeah, that's your command. You're going to be .exe, which you're going to create, right? Train model space no, not not out. It's going to be an executable file. So it's a train model space space dash output equals twain.counts.txt twain dot out, and you can do this however you want. Okay,
Yeah.
so twain counts.txt and dash vocab dash space dash vocab equals twain vocab.txt. Right, twain counts will basically have a list of all of the words and the number of times each word has been encountered. Twain vocab will have all of the words that occurred at least once. So multiple occurrences will be omitted. That's all. Yeah.
Okay, and this is our actual C++ code.
That's
This
your
is
C++
like,
code.
okay, how will this work with all of this input? How will that go in? Because this is argv, right? This is
Okay,
argv,
so,
right? In main. In main,
in
this
your
is
main,
argv.
yeah. All right. So in your main, you're going to get arg your argc argc is going to be 2 here. Okay, argv of
It's
0
gonna be
is
3.
your,
It's gonna be 3. Because
it's 3.
1, 2,
Yeah,
3.
Okay, so argv of 1 is going to be your that entire thing output. However, I thought you mentioned last time that you didn't want to do this in C++ and you could do this easily in with parsing the arguments in Python and things like that. So you're welcome to experiment with that. And in fact, if you can do this in Python, that is fine too. But I wanted you to have an opportunity to use hash tables.
Yeah.
So all this needs to do, this C++ program needs to do is read in the stream. Its output is given to it on the command line. You've got to parse it out somehow, right? Yeah, I think there's a library called getargs.
Sorry. Okay. So my question is, right? How do I get this, right? Because all these bash files, right? You said
Yes.
wrote to standard outs, right?
Each
they
one
go
writes
to
to standard out. Yeah, each one writes to standard out. So
okay,
in
and
fact,
then when I run this, when I run this C++ thing at the end, right?
yeah,
Is standard out filled with all of this? So I need to take stuff in from standard outs.
yes. No, you need to take stuff in from standard in
From
because
C in,
the
right?
output of the previous one comes to the input of you.
Okay, so here I'll be using cin instead of like a input file stream.
Yes.
It's like already opens all the
Yes.
files and
Yes.
okay.
That's why I said when you write the function being passed a stream, it's a lot easier for you in main, because in main, if you're given a file name, you can open the file name and still send the file stream. If not, you can just send cin.
Okay, so I can literally just pass in cin as a stream.
Yeah, because your function won't know any different, right? It just gets a stream.
Okay, Nathan, are you getting this? So like in our main, right? Like in our classify, right? Like in our main will be like if it's train, right? So like here we have like we're training, right? So we'd have like a minus train, or you're saying this is train model. Okay, so it'll be like a different thing, whatever. It's like train model, and then it will pass in all these stuff, and then the train main. When it actually calls the function, the frequency trainer, instead of passing in a string, will actually pass in cin, because all the stuff that we just did will be in cin. So, like, instead of all of this,
Hey, by the way, if one of you is interested in being a 2C embedded tutor next quarter, actually, I don't know, because Constantine sent email saying only 2A got cleared for tutorship this time. Last quarter, he sent email saying anyone who wants a tutor for any of these classes can get it, but I'll email him. But if one of you wants to be a tutor for CS2C, you got to be enrolled in 12 units, okay? Minimum of 12 units apparently. But if you are interested, let me know, and then I'll check with Constantine, what their plans are.
Okay. Oh, and this is the thing, but if we this, like you were saying, this, then it will work. Wow. Okay. So are you seeing this? Like we'll just pass in CN and then it takes in all of this.
So wait, what if it doesn't open a file? It will just pass in CN. What, like, I
You'll
don't
just
get
wait
that
for
part.
it. Yeah, if you don't give it a file and you run it, it'll just wait for you to punch something into the keyboard because it's reading CN.
Like in the
Right, 'cause
terminal?
Yeah.
Oh, okay.
You can just,
Wow.
you can just, if you run cleanup.sh right now, this file that Yamm just created, if you run it, and you don't supply it the file that he's created, cleanup, let's take a look at that file again. Oh, you don't have cleanup1.bash, cleanup2.bash.
Yeah, these don't actually exist, but
You can just get rid of it.
okay, temporarily I'll comment them out.
Yeah, you can comment. Yeah, put a hash mark right in the beginning of the
Yeah.
line.
And
And
don't
I think
need
you need to
this.
break the line there. You need to break the line there. No, you can break the line after the backslash. You can still have go on to the next line like you were going before, except you have nothing on the line and that's it. Enter,
Okay.
enter. Hit enter. You got to hit enter because now, yeah, great. Because I think you have to hit enter, but you can experiment and find out. Okay, so that means you can still go in and put all these commands. We can uncomment lines and stick them together. This is, play with this like Lego blocks and move things around. That's really helpful in data cleanup, because when you're doing data cleanup, what will happen is that you'll have a huge pipeline built up where all the input is coming in at the top, like the cat star, okay, and it's going to the first filter. And all the first filter does is a set command. And the set command is going to replace all the DRs with doctor, STs with saint or street, right? And maybe replacing them is not a set command. Maybe it's a C++ program that uses input from multiple sources to disambiguate. But hey, I see a DR there. Is it a drive or a doctor? So it'll do the right thing, right? So there's all these things. It'll pipe it to the first one, and the output of that is just standard output. That's it.
Got it.
Okay.
So we can just keep on adding stuff that we're piping, and each one of these do a different cleanup. So the whole point of this is that it's now modular, right? Now this is modular, so we can add however many cleanups that we want.
Yes, and you got to do this hundreds and hundreds of times for each project because you've got it set up and running, and it doesn't do what you want. And then you look at the data and say, hey, I need to fix it up. And you go to the script and say, well, I need to interchange those two filters, right? The capitalization has to happen before, the saint is changed to street. Yeah. So, and you do these things and look at the output and seeing that, you can actually see the data morph into shape. Because previously it'll just look like a jumble of stuff just coming out. Yes. But as you start making these changes, you're also starting to look at what the model is starting to expect from the stream. And so you will subconsciously start making changes to your filters so that certain aspects of it are emphasized, or certain noise is suppressed. Okay. So as it flows through the stream, you can actually visualize in many senses the data. As as you're getting transformed the right way, it's going there. And by the time your C++ program has it, its job is really simple. And all it does is basically count things. And then later on, I'll show you why you need to calculate the relative frequencies and what you do to handle outliers, words you've never seen, but they're part of the vocabulary, all those things. And because all it does is write everything down as probabilities. But the only small thing that will cross the bridge when we come to it is that we can't afford to deal with raw probabilities here, because the probability of a single word is, you can say it's like 10 to the minus 1,000, right? Each word is so very unlikely that a combination of multiple words together which is really what we need to make a classification decision, is an extremely small number. And it's going to result in underflow. We can't represent it in double. Right? So at that point, we will say we'll not work in ordinary double space, we'll work in log space. So we never work with the actual raw probabilities, we work with log probabilities. And therefore, instead of multiplying probabilities, you can just add log probabilities, because log AB is the same as log A plus log B, right?
Wait, but then we can have negative probabilities, right? Because if we're doing it log.
Yes, everything will be negative then. So everything will be negative because your probability is between probability is between 0 and 1. So when you take the log, everything is going to be negative now.
Okay.
So you have to take the negative log probability if you want to maximize, or something like that, right?
But doesn't log go to negative infinity? Doesn't log go to negative infinity?
Yeah, that's only for something that you would never encounter in the data, something that has 0 probability, right?
Right.
If something has 0 probability, then you cannot encode it.
Okay.
Yeah, you can only encode something that you expect to see. If you have no expectation of seeing something, you'll never see it because it'll never be recognized by a finite recognition system.
Okay.
Yes.
But if we have like a word that's like 1 in 10 million, right? It would be like a huge negative number, right? Maybe we'll get an overflow.
Yeah. No, it won't. When you go into log space, it won't. You'll be surprised. You know,
Okay.
all these huge, extremely small numbers only look small in ordinary space. When you go to log, everything is so scrunched up.
Even, but like log.
Yeah.
But
10
log
orders
of
of magnitude.
but log of like 0.0001, right, is like a negative 10 million, right?
What? Log of 0.0001?
Yeah.
No, that is just -6. Isn't it? Or something. It's a small number.
Oh no, you're right. Yeah, you're right.
Yeah.
Wow.
The log curve is actually very nice. Both the e to the x curve and the log curve, they look very nice. If you go to Desmos and do it now, no, you don't have to do it now. You can look at it. It's very nice. It's also monotonically increasing, which means you can do a lot of really nice things with it. Doing argmax, when you maximize a sum or things like that, you just use a log function when you cannot use a raw function. And instead of maximizing a product, you just maximize a sum now. Yeah, because you're in log space. So there's lots of really cool things that open up, but there's a few small challenges that we can solve when it comes to it. But getting this to work is the hard part. Okay, getting the cleanup and the pipeline working is hard. Tightening the nuts and bolts, that can happen after the thing is in place. Yes.
Okay.
That's basically all. If you have so all we need to do is when you run the program, it's just got to produce those 2 files. It's got to produce a counts file, which basically has all of the words normalized, which has come through your filter, right? So, and before you send it to your C++ program, you can just do a pipe to more, and so you can see it on screen.
Pipe to more?
Yeah. So if you go to you type SEQ and type the 1000. For more and paginate it. You hit enter.
And what?
Type less.
Yeah, less. Yeah, okay.
Yeah, no. Up arrow, and then instead of more, type less.
And then isn't it like W and stuff like this for the less command?
No, I think it's just less. Yeah, you hit space, it'll go to the next page. It looks like VI, but it's just. But if you hit B, it'll go to the back previous page. And it's just like VI commands. You can hit K to go 1 line up, J to go 1 line down.
Nice.
And then less than takes you all the way to the top. Greater than takes you all the way to the bottom. And then Q gets out of it.
Yeah.
And then if you say -C, it'll paint from the top to bottom of each page, so you don't have a flickering your no space after the dash, just less space -C. Q.
Oh yeah. Sorry, I didn't see that space.
Yeah, so you can do the man page for this later on. So what you can do is before you send it into your your C++ program that does the counting and dumping, you can just pipe it to less, and you can see the output of all of the twin things after pre-processing. So what you have in your cleanup.sh is all the pre-processing. And then the final output, which is really, really clean, that is what gets sent to your C++ program. which will do the actual
Okay.
counting. And it needs to be C++ right now because it's not, you will eventually start going to log space and using the math library for a few functions, and that'll be more efficient in C++. Even if you use Python, it's going to hook into something like that. Yeah,
Oh, yeah,
NumPy or
of
something.
course. Yeah.
All right,
Okay.
that's basically it. Is that enough for a couple of days?
Okay. So just to understand the flow, okay? If we can go over the flow one more time, okay? So like the way that it will look like is like this. So I have we have data here, okay? So it'll be like dot slash data slash
Yeah,
what do we have in
twain.txt.
there? We have
Authors, yeah.
authors, and let's see, what do we have in there? We have Bill Kendrick. Okay, let's go.
Yeah.
So this is like a huge his
Oh,
book.
you have,
Okay,
that's really cool. All right. So essentially what you'll have is that you're going to pipe that.
right. So we'll pipe this.
Yeah,
onto...
and pipe that to these are all dash my dash cleanup scripts one after another.
Okay. So this could actually also be a script, right? Because this could be like all cleanup dot bash, right? Like this could be a bash script of its own, right? We don't have to separate them each once.
Yes.
And
we could call other scripts.
Sorry?
It could call other scripts, obviously, right?
Yeah. It will call all the scripts, right?
Yeah. And then pipe that.
We'll pipe that into our actual C++ code, right?
That will
.exe,
which will output your vocabulary and counts in 2 files that are named on the command line.
Wait, okay. Wait, so it won't write them? It won't write them immediately?
Yeah, no, I think it should write them. I think, well, you could basically say type there, say C++ code.exe space vocab.txt. The first argument is always a vocabulary file. You don't have to parse your arg and all. So the first argument, assume it's the vocabulary file. No, don't say dash name equals, just say vocabulary. Then you can just use argv1. You don't have to fiddle around with get args. Yeah, space counts.txt.
Okay.
Now, that's all it's going to do. And after this returns, in your script, you can rename vocab.txt to whatever that particular, Bell Kendrick dot accounts.
Yeah. Like add the thing.
Yeah. Or you can say, C++ code.exe. You can give it one flag. You can say, go before the V in vocab. Go before. Yeah. All right. Dash author. You don't even have to say dash author. Yeah. Whatever. You can say that. And then it'll say bell vocab.txt and bell counts.txt.
Cool. Okay, so
awesome.
That's like the flow of it, right? So we'll have a bunch of like cleanup, and then our actual C++ code is gonna be the simplest thing ever, right? It literally
It'll be the simplest
everything
thing,
space limited, right? It just takes a bunch of C-ins one after another, adds them up, divides. You're saying like a bunch of log space stuff, so that'll be easier.
No. Let's forget about that for now. Just dump the raw counts. The word V occurs 500 times. And so on. Just the raw counts, and then you can take a next step. The next step could be another C++ program that will read in the raw counts and transform them into probabilities or log probabilities.
Okay, Nathan, I'm super interested in these bash scripts and like actually making like an overall bash script and everything. Do you want to like do the C++ cleanup, right? So not the cleanup, the C++ like the hash table that actually like adds everything up and will get us the percentages. And I'll try playing around with the bash scripts.
Yeah, as you see fit. You can just talk to her offline and divvy it up. I'm pretty sure you'll both find both of this, all of this pretty exciting.
It's insanely cool.
Yeah. It'll be very useful, and hopefully it'll turn into something that that you can generally use in other things. Whenever you're ready, just let me know. Okay, tomorrow I got a class in the morning, and then after that I might be free, but when you're ready and to go to have something else to show, just let me know. Even if you have questions, that's fine. Okay.
Could I ask you some questions before you go? As this C++ code, right? Is it able to access the arguments that went into cats, or is that gone already? those are long gone.
Oh, is it able to access what?
The arguments that went into cat here.
No, you can't. You know that
can't.
it's a shell. The shell reads that argument and sends it to cat. No, cat gets the argument. So the shell reads the argument, sends it to cat. Cat reads that file, and then from that point onwards, nobody else knows about it.
Nobody else knows about those arguments because those arguments, that argument stream was like rewritten when we did all cleanup.bash that had 0 arguments, right?
Yes. In fact, all cleanup.bash only sees the stream of words coming out. It doesn't know where it's coming from. Could be your keyboard for all it cares.
Yeah, cool. All right.
It's very nice. This kind of thing is very powerful to get the hang of. It lets you tie things together much more efficiently than you can do with GUIs. These GUIs generally have a lot of mechanical motion associated with even simple tasks. Whereas here you can minimize on the mechanical motion and just run it closer to your mind speed when you're on the command line.
Yeah. That's awesome.
All right. Okay.
Okay.
If you don't have any other questions, just feel free to. We can end the meeting now and let me know later.
Actually, I think we had. This is fine. We don't care about this, and this is fine. And you answered what the best way to do string parsing is. Okay, yeah, you actually answered all our questions from one question.
Oh, all right. Okay, cool.
Okay,
I
good.
read all of those, but I'm happy that all of the questions got answered. Great. You can just send me an email later, or or write them up like this, and we can have another meeting when you guys are ready.
Sweet.
And it's important to keep the C++ part of it as
Simple as possible.
as simple as possible, because that's where eventually all the mathematical and the logical complexity is going to go. The cleanup is all very straightforward, so we should all keep the straightforward work out of C++.
Okay.
It's already complex enough, so we try to keep it simple. All right, I'll talk to you guys later. Okay.
Yes.
Okay.
Thank you very much.
Thank you.
Bye.
Bye. That was a lot.
That was so cool. I mean, I think we have to pretty much change like our entire design philosophy, right? So, like he was saying, like make everything C++ as simple as we can, right? And just like have a bunch of bash scripts that do all the simple things, like he was saying, like all the different cleanups that we want. That's so easily done in bash. It's so hard to do in C++. So just let bash do all that. And yeah. That's
Okay,
so cool.
let's hop on Discord.
Yeah, let's hop on Discord.
You'll have to help me with those bash scripts.
Yes,
yes, I know
100%.
nothing about that.
Okay. I know about a 10th more than you. So that's it. All right, let's all Discord.
Okay.